Okay, this is a question related to effect of impurity on the melting and the boiling point. Freezing point is same as the melting point because the only difference in the term melting point means when a solid change to liquid, and a freezing point means when a liquid change to solid, but it's the same idea. So this can be a melting point as well. Now the question is, a pure water has a boiling point of 100 and a freezing point of 0. So water boils at 100 and freezes at 0. What is the boiling point and freezing point of a sample of aqueous sodium chloride? The term aqueous sodium chloride means salt is added to water, because aqua is the term which is used for water and sodium chloride is a salt, so it means a salt is added to water, or we can also say water is impure. So if the water is impure, the pure water boils at 100 and it freezes at 0. What is the effect of the impurity, or when the water is impure, what is the effect on the boiling point and the melting point? So what is the right option here? So the boiling point should increase when it is impure, and the freezing point or a melting point should decrease. So pure water boils at 100, but because it is impure water, so it should be more than 100. So more than 100, either C or D. And when you check the freezing point should decrease. It is 0 for pure. For impure, it should be less than 0 and smaller than 0. That is -2. So C is the right answer for this question. And another question, question 6. What could be the right answer for question 6? Impurities changes the melting and the boiling point of substance. Sodium chloride is added to a sample of a pure water. How can addition of sodium chloride affect the melting and the boiling point? Here C again. Why? Because the melting point decrease and the boiling point will increase. So C is the right answer. So simply impurities will lower the melting point and increases the boiling point. Then a technique which we call a chromatography. Basically what happened in this technique, we can check whether a substance is pure or impure by using the melting point, by using the boiling point, or by using a chromatography. And there are different types of chromatography. Basically you're studying paper chromatography, in which we use a paper. How we use this technique, how we use chromatography. So first what we do, we take a paper. This is a paper. This paper is known as chromatogram. You should be able to label this. So this paper is known as chromatogram. Then we'll take a container, and before taking the container, we will draw a line with a pencil. At the bottom, we will draw a line with pencil, and that line is known as the baseline or origin. How this technique works? So example, if I have ink and I want to find whether this ink is pure or impure, because to check whether a substance is pure or impure, we can use a chromatic, we can check the boiling point, we can check the melting point, or we can use chromatography. So how a chromatography can be used to identify whether a substance is pure or impure? So what we will do, we will place a sample here, a drop of ink which we want to find whether it is a pure or impure. That is a sample. And we will take a container, fill with a liquid, a solvent in which this ink can dissolve. Like normally we use water, but not always water, because some substances are not water soluble. So we take a solvent here, a suitable solvent. And what is the meaning of suitable solvent? A solvent which can dissolve the sample. Now what will happen when you place this chromatogram into a container which is filled with a solvent? So this chromatogram, it's a paper, it is like a filter paper or a tissue paper. So it will absorb the solvent. So when it will absorb the solvent, or it will soak up the solvent will rise, the solvent will rise on the chromatogram. This is how the solvent will rise. Like this is a position of a solvent right now. But when you place this chromatogram, the solvents start to rise. Because what happened, this paper is having a tendency to soak up the moisture or solvent. The solvent will start to move up. It will rise to certain point and then it will stop. And as the solvent is rising, the sample will also rise with the solvent, and sample will move to new position. As the sample move to new position, if we are getting more spots, or if we are able to see more spots or more than one spot, it means it is impure. But if it is only one spot, it means the substance is pure. And the last position where this solvent rises, that is known as the solvent front. The last point where the solvent rises, that is simply known as the solvent front. So this is how a chromatography technique works. We take a chromatogram, we draw a line with pencil, the origin, then we place a sample, and we place a chromatogram inside the solvent, suitable solvent. When the solvent rises on the chromatogram, it will take the sample. If we see only one spot, it means the substance is pure. If we see more than one spot, it means the substance is impure. Is it clear? The concept of the chromatography. It is normally used to identify whether colors, dyes, inks are pure or impure. Like you can see here, this paper is a chromatogram. So what we do in a chromatography, a technique known as chromatography, we take a paper, you can see this is a chromatogram. We draw the origin, the line with pencil. This is the origin drawn with pencil. Then we place a sample here. Like example, we want to find whether this brown ink is pure or impure, or this brown color is pure or impure. So we place the sample on the chromatogram, and we dip this in a container which is filled with a solvent, a liquid. So when we place this in a liquid, the liquid will rise on the chromatogram. So as the liquid is rising on the chromatogram, it will take the sample with it, and if we are able to see more spots, as you can see, 1 2 3 4. So if we are able to see 4 spots, it means this brown ink was, or this brown color was impure. But what will happen if there was only one? So we take chromatogram, we draw the origin with pencil, we place a sample, and we dip this in a suitable solvent. So we dip in a suitable solvent. Now what happens? This chromatogram will have a tendency to absorb the moisture, soak up the solvent, so the solvent will rise. As the solvent is rising, so the spot will move from the origin to new position. But if we are able to see only one spot, it means that the substance is pure. But if we are able to see more spots, it means the substance is impure. Is it clear how a chromatography can be used to identify the type of substance, whether it is pure or impure? Like here, you see a chromatogram, a simple chromatogram. Is it pure or impure? The ink which we are using, the original ink, is it pure or impure? It is impure. Why it is impure? Because you can clearly see three different regions, three different spots. So it means the substance is impure. Same thing here. You can see different regions are there, different colors are there. So it means the substance is impure. Now the question is, which color here is more soluble in the solvent? A, B, C or D? The question is, which color is more soluble in solvent? A is more soluble. That's the right answer. A is the correct answer. Why? Because A rises to a greater distance. A move with the solvent to a greater distance. So it means A is more soluble in the solvent than B, C or D. And there's also another thing which we call, that is the RF value, or we call a retention factor, also known as RF value. And how we calculate this RF value? There's a formula to calculate. D is not impure, the whole substance is impure. It's not about D. The whole substance is impure, which contain four different substances: A, B, C, and D. A, B, C, and D are mixture which are present in the original sample. Retention factor or RF value. What is the RF value? It is a distance moved by the spot from origin divided by distance moved by solvent front from origin. So we calculate retention factor or RF value. It is simply a number which we calculate for different samples. Example, This is a chromatogram. Yeah, that I will explain what is retention factor. Example, you have a chromatogram. This is the origin which you draw with pencil, and you place a sample here. When you place a sample, you observe two different spots. So the question is it pure or impure? The sample. So the sample is impure. Why the sample is impure? Because it has more than one spot, so that's why it is impure. And we calculate a retention factor. What is a retention factor? It means it's a ratio between a distance moved by a spot to a distance moved by the solvent. And how we calculate this? Like example, if this is a solvent, originally the solvent level should be below the origin. When we start the experiment, originally the solvent level should be below the origin, otherwise the sample will dissolve directly in the solvent. So when the paper will soak up the solvent will rise. As the solvent rise, the sample also rises with the solvent, and at certain point it will stop. When it will stop, the last point where the sample rises, the solvent rise, that is known as the solvent front. So what is the retention factor or RF value? The formula for RF value, example, if I say RF value of A and sample A. So RF value of A is equals to distance moved by the spot from the origin. So what we will do, we will measure a distance moved by this spot from the origin. So we'll take a ruler scale and we'll measure this distance. Example, this distance was say 5 centimeter. So the distance moved by the spot from the origin is 5 centimeter divided by distance moved by the solvent. Example, the solvent rises to 10 centimeter from the origin. Distance moved by solvent from the origin. So from origin it rises to 10 centimeter. So what is the RF value? Retention factor, distance moved by spot divided by distance moved by solvent. So 5 divided by 10, that's equal to 0.5. And it does not have any unit, so it is only a number. It does not have any unit, centimeter, meter, millimeter, because it is the simplest ratio. So the RF value for spot A is 0.5. What about the RF value for spot B? If the distance moved by spot B is example 3 centimeter. So distance moved by the spot divided by distance moved by the solvent front from origin. So that will come out as 0.3. So normally, and if a question is which is more soluble, A or B. So how we can work out? A move to a greater height, A move to greater distance from the origin as compared to that B. So A is more soluble in the solvent as compared to the one which rises more, or the one which is having a higher RF value is more soluble. So in this example, the correct answer is A. So A is more soluble than B, as A rises to a greater height from origin as compared to that of B. Yes, Abdullah?
Sir, but before some minutes you told
Hmm.
that the sample is more soluble.
Hmm.
So, upper, like,
The one which rise, look what happened, the one which is more soluble, it will move with the liquid to a greater distance. So which point move to a greater distance, A or B, or which dye or color move to a greater distance from origin in this example?
sir,
So
but B is still soluble because it
B
have
is
some
still soluble. B is still soluble in solvent, but amount which is more, the substance which is more soluble. I'm not saying B is insoluble. What I'm saying both are soluble, but which is more soluble? So A is more soluble as it rises more or greater distance with the solvent as compared to that of B. So simply using the RF value, you can also work out the solubility, that if RF value of a spot or a dye is greater or color is higher, it means that substance is more soluble. Is it clear?
So sample is the least soluble.
No, no. Sample is a mixture of A and B. This is a sample which contain A and B. So A and B are the two substances which are present in the sample. When you remove this, so this spot will not be here. It will be vanished. Like it won't be here. And what you have, like on the origin you put a sample, but once the sample rises, the sample will no longer be on the origin. The sample will actually separate into A and B. Now it will be like this. So basically what happened, there was a originally sample, but when a solvent dissolved A and B, so A and B separated from the sample and at different positions. Is it clear?
Yes, sir.
But because it's not a like animated figure, that's why you may be confused that a sample will still be there and A and B rises. But what actually happened, look, if I make a phases, so this is a chromatogram. You draw the origin with pencil. Why I'm every time saying draw origin with pencil? Because if you draw with ink, then the origin will also move. Like if you draw the origin with ink pen, because the ink is soluble in water, so it can also move and change its position. So we don't draw the origin with ink pen. We always use a pencil, because that particle graphite is insoluble. Graphite and clay are insoluble. So first we place a sample here. This is first what we do. The solvent level should be below the origin. Then when we leave it for some time, the substances which were there in the sample will rises above the origin, and the sample will not be there because the substances rises. So as it rise, the spots, like example, we have three different spots. So it means this substance consists of three different other material, which is A, B, and C. Is it clear? So this is at the start and this will be at the end. Is it clear to everyone, the chromatography? Now some questions related to chromatography, like example, we place, draw the origin with pencil, we place a sample, and we use a liquid, a suitable solvent. So the solvent will rise. The sample does not rise. Solvent. What you can conclude about this, or what you can say if a sample does not rise with a solvent? So what you can say about this? what we can say, like we place a sample, we use a solvent, the solvent rises, the last point where the solvent rises, that is called a solvent front. But we don't see the sample rises with the solvent. What I can say about this substance? If a sample even it's not, it's like one spot is there, but that even does not rise. So if it does not move from the origin, what we can conclude or what we can say, we'll say the sample is insoluble, or the sample does not dissolve in solvent. So this sample is insoluble. Insoluble means that does not mix with the solvent, so it cannot rise with the solvent. That's why it will remain on the origin. Is it clear? So whenever you see a spot remain there or a sample remain there on the origin, what you can say? You can say that you are not using a suitable solvent. So we should change a solvent here in which the sample can dissolve and move. If a sample cannot move above the origin, we can simply say that the sample is insoluble or does not dissolve in the solvent. And when the highest solvent rise, like if one which rises to a greater distance, it means that will have the highest RF value. Another thing, example, you have unknown substance X and you're checking this X with different substances A, B, C, and D. These are the spots which you see for X. So first thing, this is X and you have like five different chromatogram results for X, A, B, C, and D. The first question is, the X is pure or impure? What about X? X is impure. Why? What you conclude? Why it is impure? Because there are more than one spot, so it is impure. That is one thing. So X is impure because there are more spots. So we conclude that it is impure. Now, if we check the substances present in X, instead of saying more particles, yeah, you can say more spots are there in a chromatogram. What are substances present in X? So now we are checking what are the substances present in X. If we check A, if the same substance present in X, they will have the same positions. So A is present, yes or no? X contain A, yes or no? So yes, it contain A. What about B? When we check B, if X contain B, then what are the spots it should have? It should have this spot and there should be another spot. Okay, Abdullah, I will repeat. Look, you have a sample, you have a substance X, and you're finding what are the substances present in X. X contain A, B, C, or D. So how you can find whether X contain A, B, C, or D? So what you will do, you will draw a line from the spot of A, draw a line, and check whether the same spot is there in X. If the same spot is there in X, it means that X contain A, because you can see the position of spot of A is same as position of spot of X. So it means X contain A. Is it clear? This point, Abdullah? Yes, Abdullah?
Sir, B is also, we can say it's X is equal to B.
But now, when we are checking X is equals to B, B is having two spots. So both should be there in X. If B was present in X, then both should be there.
So C and D are exact same position as
Yes.
X.
Yes. So in that case we can say. So when we check for B, one spot is matching, but the other one does not match. So it means the sample B is not present. So B is not there because one of the spot of B is matching and the second one, for B, it does not, because both spots should, if B is there, both spots should be there in X. So one is there but the other one is not there. It means B is not present in X. What about C? When you check for C, so you will draw a line. It is exactly matching. So it is C is there. And what about D? When you check for D, it also matches. So actually X contain A, C and D. Is it clear? And your question, sign, X is not with A because A is pure. So A is pure. Pure substance can be present in impure substance because X is a mixture. So X can have other substances. A is a pure substance. Is it clear how I identify X contain A, C and D? So another example. This one is X, A. So first thing, X is impure. What X consists of? So when we check, we will check different regions. When we check for A, is A present? So when we check A, one of the spot is there from A, but the other spot is missing. So is A present in X? A is there? Yes or no? So A is not there. So X does not contain A. When you check for B, one of the spot matches. So that is there. But the second spot is missing. So B is also not there in X. What about C? The C is the spot matches one of the spot. And what about D? That also matches. So we can say X contains C and D. So X is an impure substance which is a mixture of C and D. Is it clear to everyone, the chromatography technique? We will do more questions next session. So what we discussed today, that we started with a basic concept. The learning objective for today's session was learning to check how, the purity of a substance, whether a substance are pure or impure. Different apparatus we discussed we can use mainly for volume, and if a substance is pure, it will boil at fixed temperature. It is impure, it will boil and melt at different temperature. And we can check the purity of a substance by melting point, by boiling point, and by chromatography. If a substance is pure, we'll get one spot. If it is impure, we'll get more spots. Like example, if a student draw the origin with ink pen, this is what happened. Like, what is the mistake here? The mistake here is student draw the origin with ink. So when he draw the origin with ink, so when the solvent rises, the ink will also rise with the solvent. So it will not be a right method. Whenever we draw the origin, it is always with pencil. Is it clear? Any question related to the class today? Today we discussed the melting point, the boiling point, as well as the chromatography and how it can be used to check the purity of a substance. We have to increase the amount of water for which condition? In a container we have a water, it's enough water, we don't have to add too much water because already we have water in a container. So when we dip this chromatogram, so chromatogram take up some of the water or a liquid. Yes, Abdullah?
What was the mistake that that student did?
The student, the RF, he drew the origin with pen, ink pen. That is a mistake. Like here, a student drew the origin, but that for this he used ink pen.
So we also use the ink pen,
No, we should use a pencil to draw the origin.
but we are checking for the ink. So why would we use the pencil?
Yes, Abdullah. So,
We put a drop the sample of a ink. So why would we use pencil?
so why we use a pencil to draw the origin? Like this origin, this is a line which we draw with the pencil, and then we will place a drop of ink here. This line which we draw the origin, that is with pencil, and this is a drop of ink here which is placed, that is only the ink part. Why we did not draw the whole line with the ink? Otherwise what happened, whole line will rise with the origin, so we cannot identify exact position of the origin. So only the spot will rise and the origin will remain. That will make it more accurate to measure the RF value. Clear? Like here we will have origin with pencil, and when the spot will rise, it will rise above the origin. Is it clear, Abdullah?
Yes, sir.
Okay. Anything else? Any other question related to the class today?